Welcome to SM Physics again. Here is the figure and the problem is here. Find the acceleration of the block of mass small m. That means the small m mass is here and another block 2m is here. So you have to find out the acceleration of this block, and the friction is frictionless. All the system is frictionless, and pulleys and the springs are light. That means mass is not neglected. Mass is neglected on the pulleys and the string. Okay. So here in this case, before starting this problem, first of all, I discuss the inclined position of a block. This one is the inclination by inclined plane, and the block is here. Suppose the mass of the block is m. Now the mass is acting, mass means weight, is acting in the downward direction, and that is mg. Now according to Vector's rule, we divide this force into two components. One is horizontal, another is perpendicular. Now this angle is theta. By geometrical proof, this angle is also theta. Now one trick you have to remember, that theta attached component will be cos component, and without theta, that is sin component. So theta attached component is this component, that is mg cos theta, and this one is mg sin theta. Clear? Theta attached component is this component, that is mg cos theta, and without theta, that is mg sin theta. So if the body is in equilibrium, then mg sin theta, and suppose let a force will be acting this way. So F equal to mg sin theta. F equal to mg sin theta if the body is in equilibrium. Now I have to consider the vertical force. One is mg cos theta, and normal reaction act towards the upward direction, that is r. And the body is in equilibrium, that's why r equal to mg cos theta. We can write it. This is the equilibrium condition of the body when the body is in inclined plane, inclination theta. Angle. Clear? Now I love this one. Just you take the screenshot of this figure. Now I consider the block N, which is on the inclined plane. Now the previous you already take the screenshot. So here this mass is divided into two components, and the theta is given here, that is 30 degree. So mg cos 30 degree, and this one is mg sin 30 degree. And the string tension is acting in the upward direction. So this one is the FBD1, that is the free body diagram 1. Now let the acceleration of this thing is downward direction, and this one in the upward direction, that is A. Now if the net force will act in the upward direction, that means the upward force is greater than the downward force. So what is the upward force here? That is the tension of the string, and the downward force is mg sin 30 degree. So tension T is greater than mg sin 30 degree. Clear? So T minus mg sin 30 degree. That means I have to find out the net force which act on this block, and due to that net force, the body will move in the upward direction. So that means that is equal to ma. This is the equation number 1. Now I simplified t minus mg, sin 30 means half, that is equal to ma. Now 2t minus mg, that is equal to 2ma. This is the final equation. This is the final equation you can write. 2t minus mg is equal to 2ma. Again I repeat, the body is on the inclined plane. The angle is 30 degree. Now we resolve the weight into two components. One is mg cos 30 degree and another one is mg sin 30 degree. The normal reaction R, which is just opposite to the mg cos 30, and tension T is acting downwards. This is the greater than mg sin theta, because the net force, the body will move in the upward direction. That means the net force act in the upward direction. So we write this equation. You just take the screenshot here. Now I take the another block. The mass is 2m. This one is the FBD 2. Now here you see the weight is always acting downward direction. So this one is twice mg because the mass of this block is 2m. And the tensile force will act in the upward direction, that is 2t. Now one question is arise, why I take 2t? Because the previous I take the tension as t. So here you see the tension here, this one is t, but the net tension, this one is 2t. When 2t is divided into two segments, then we get one arm T as a tension and another is also T. So 2T is there. That's why I take 2T. And another one is, in the previous problem, I already told that if the tension is half, then the acceleration will be double. And if the tension will be double, the acceleration will be half. So here you see, the tension T is here, the tension will double, that means the acceleration of 2m will be half. That means its acceleration a by 2, which is in the downward direction. Because this one is the upward direction, that means this one is the downward direction. Now the net force is 2mg minus 2t. Why? Because the body moves in the downward direction. That means the downward force will be greater than the upward force. So here the downward force is 2mg and the upward force is 2t. So 2mg is greater than 2t in this case. Now I write down the equation. So 2mg minus 2t, that is equal to 2m into acceleration will be half, I already told, so a by 2. Clear? So 2 eliminating there, twice mg minus 2t, that is equal to ma. This is the number 2 equation. You just take the screenshot and I will be rub it due to lack of space. So this one is the 2mg minus 2t is equal to ma, that is the second equation. And the first equation was 2t minus mg is equal to 2ma. Now I have to solve it. So 2t minus mg is equal to 2ma and minus 2t plus 2mg, that is equal to ma. This one is the number 2 equation. Now by addition, so this will be eliminate mg, that is equal to 3ma. Now m also eliminate there, so a equal to g by 3. So the acceleration of the block M will be g by 3, and this is the solution of this problem. Thank you.